Yeah, definitely a burr right there. Hey, welcome back everybody. Yeah, we're back on the Enco 4-jaw chuck project. So what we're doing is regrinding the D1-4 taper in the back of the chuck and also the back face of the chuck as well. And this is uncharted territory for me. Haven't really done this type of grinding before, so it's a learning process. And spoiler alert, it's already done, and it went pretty good. We had a few surprises at the end with what we measured on the chuck. So be sure to stick around and check that out. And I've got a few questions at the end that hopefully you guys can help answer. I think we're kind of on the right track, but kind of an unusual finding. I've got like 6 hours of video that I had to pare down to, under 30 minutes. So it might be a little choppy. It may jump steps a little bit, but I didn't want to put you guys to sleep either. So let's get right into it. Okay, thanks. This is a bit of a janky setup, but I just want to make sure there's no major issues. Just want to sweep the back here in comparison with the face. So far that's looking pretty good. Try not to bump it here. So that's a half thou. Let's come back around over here. Yeah, same reading. Okay, I've gone around and I've swept all these guideways for the chuck jaws, and they're not bad. That looks pretty good. I think they're all within a half a thou. Okay. All right, so I reached out to Tangent Engineering, that's Jimenos, and picked up one of their sine bar kits. It's designed for lathe compounds. I got the 4-inch, which matches mine. These are really nice kits, guys, and I'll put a link down below to their website. I don't think this is on the website right now, but you can just email them for pricing and so forth. This is really a slick setup. So you've got a magnetic sine bar, and I'm sure most of you have seen these, with precisionally spaced pins. They're 4 inches apart. It's got rare earth magnets to hold it down onto your compound, so you don't have to hang on to it while you're trying to set everything up. And it even comes with the gauge blocks already set up for the different Morse tapers. So there's a bunch of different gauge blocks in here. I don't want to take them out, but we'll take the cover off. They're all nicely marked what they're for, which Morse taper, and what the dimension is. That's pretty slick. And then he's got all the charts for your typical tapers in here. Morse taper, Jarno taper, Brown and Sharp taper. So you don't have to do any math, it's all done for you. I looked up the information on our D1 taper, and they all have the same nose angle. 7 degrees, 7 minutes, and 30 seconds, okay? Which works out to 7.12479 degrees, all right? Okay, so, and that's like an 8-to-1 ratio, which we're gonna need to know that when we start grinding, because whatever we take off the taper, we're going to have to possibly take off the face as well. Okay. All right. So I just went and I used two different ones just for a sanity check, but I just went online and found a couple different sine bar calculators, put in the sine bar length or degrees, and it shot out the gauge block thickness that we need. Well, both of my 10th indicators are having issues, so I actually ordered a new 10th dial test indicator, and I ordered a new Noga arm, which came in yesterday, but the indicator's still a couple days out. So I've resorted to a 1/2 indicator, and honestly, trying to bump in the compound any closer than that is almost impossible. But I got us pretty dang close. And we're barely getting any needle movement at all, and it took quite a while to get there. And just to show you that it is a real reading. Okay, so we're going to call that good. Just a quick sanity check after the skim cut that we made. Okay, that should work. I set this up off camera. You can see I got copper pads in there, so we got a little bit of flexibility. So here's our face run out. Got it within a 1/2 thousandths. All right, here's the radial run out. It's also 1/2 thousandths. Okay, so I put a tenths indicator in, and we're checking the run out and the concentricity of the tapered inner bore here. And the total run out is right about 1 thou, kind of what we were seeing on the exterior diameter. And then when we come around to here, which we know is a little low, and it's reading low, as compared to like over here, that's a little higher. Okay, yeah, like here. Okay, let me move in to the inner part of the taper. Okay, so we're on the inner part of the taper. It's still low in this area where we know we have a problem. And as we come around, it's a little better. Okay. Anyways, that's what we're starting with. Just double checking that our compound angle is still matching the taper angle. It's feeding out. There's a little bit of roughness, it'll jump around a little bit, but the average looks like it's staying on track. So I'm hoping our taper will clean up with just about a 1/2 thousandths, 5/10 off the diameter, which would only be, or works out to a 4 thousandths feed on the carriage travel. But we're going to go a little at a time because we definitely don't want to overshoot what we need. We're only going to take off the absolute minimum. We're just going to touch off first and just see how it goes. Under. No contact yet. I'm just going to go in. contact there. Getting a little bit of contact there. With the carriage valve. Let me reset this guy. Okay, we're getting some contact. Okay, let's feed in another valve. Alright, let me have a look. Looks like we're taking off a high area right there. Okay, we're definitely removing material here. Nothing here. Okay, so we're just working on a high spot there. Let's have a look. So the only place we have blue left is where it says no contact, where we had our egg shape reading originally, and also when we blued it with the spindle nose. So that's matching what we expected. Looks like we need to take a little bit more. We're getting close. We've still got a little bit of blue here. Okay, there's just a hint of blue left over here. I think we're just going to leave that. All right, I think we're going to quit while we're ahead. So our total in feed, 12 thousandths there, 10 thousandths here. There's a good possibility we're going to have to take some material off this face, but we'll do a test fit first. Clean everything really good. I don't want to have any grit get on the spindle nose. I'm going to do it one more time. I wiped off as much of that bluing as I could, but I think I'll clean it one more time, because you get a false reading if you have too much, but that doesn't look too bad. Okay, I did this one off camera and had a little better results trying to hold this thing. So, and I was only rotating it about 1/8 of a turn, you know, back and forth this way. And we've got mostly blue contact all the way around. Might be a little thin right there, although it does have contact. Okay, so I think we're pretty dang close. I think the taper's fine, but we may have to take a little off of here. I won't know until I can hold it on there better. So I'm going to go ahead and break this down. That way I can just do the chuck by itself. And what I want to do is see if there's any rock back and forth. As long as there isn't any of that, we're probably fine. If I can feel a little bit of movement, then we're going to have to take some material off of here. All right, so we have just a little bit of side-to-side play. So I got to take a little bit off of this surface, probably, I'm guessing, about 2 thousandths. Okay, so we're doing some math and some thinking and some calculations, which is not good for me. Trying to determine how much we need to remove off this face so that we can get a simultaneous fit up of the taper and the back of the spindle when everything's mounted up. Before we started, we had a gap when we did a test fit to the lathe spindle, and hard to measure, but I estimated had about a 4/1000 gap. Well, that gap is gone now. So then we also kept track of how much we were feeding. We were feeding with the carriage to increase our depth, and it's an 8-to-1 ratio. My guess is we removed 1/1000 of diameter from the taper. Okay, so if we plug that into our 8-to-1 ratio, that's 8/1000 we would have moved the taper in, if that makes sense. Okay, but then we already had this existing gap of 4/1000, so just doing that math, I came up with we need to remove 4/1000 from this face. Okay, but we did feed in. When we were feeding, we were keeping track of how much we fed in 12/1000, but we're also consuming the grinding wheel as we're doing the grinding. So it's, you know, there's a gray area there. Okay, but I think what I'm going to do is maybe just take 2/1000 off and then break everything down, do another test fit. I would rather do that a couple of times than go too far. The other thing is, how do we know how much we're removing? And I've been trying to figure out a good way to measure that, and there's really not a good way. But I am going to use this plug here, which is the pivot point of one of the jaws. This one here is pretty smooth, and we don't have any features around this particular spot. So you can see I put a witness mark, and if I come in with our depth gauge and I line up to the top of the register here and center up on our witness mark, which will stay because that's below the grinding area. Okay, and take a depth reading. And I've done this many times already. Okay. We're coming up with 84/1000 depth right there. Okay, so I think we can use that to monitor our progress on how much we're going to be grinding. Okay, and I still have to dress the wheel. I may end up just doing a hand dress on it. So I still got that to figure out. All right, well that was weird. We tripped our GFI breaker. Well, this is a universal motor, so it's got brushes. So maybe some of that grinding dust got in there and maybe it did some arcing on the brushes. I switched it to a non-GFI. Seems to be all right, so let's keep going. Okay, we got a scratch where I did the heavy-handed touch off. But I think we're going to take a measurement just to see where we are before we go any farther. All right, we've removed 1 thou. Okay. All right, I'm going to make another pass. I think if we get rid of this scratch, we'll probably be pretty close. Okay, we've taken off exactly 2/1000. I'm going to do a couple spark out passes, and then we'll break it down and do a test fit. My rough calculations came up with that we needed to remove 4/1000, but I would rather test it now and have to put everything back together again than go too far. So we're going to checking if I can feel any side to side. I don't feel any side to side movement, but it still could use maybe another thou off so that we get a tighter makeup to the face, so so it makes a stronger contact to the taper. Okay, I think we'll take one more thou off tomorrow. All right, we're all set up again. So we're taking our first cut after getting everything set back up. I also redressed the wheel, so we got a fresh, clean dressing on the wheel. All right, well, we've removed exactly 4/1000. I wasn't planning on taking that much, but our wheel was definitely more aggressive after giving it a fresh dressing. So we took a little more than we were planning on, but that's what our calculations showed we should be taking anyway. So hopefully we're there. We've got a nice finish. What I've noticed, and I'm completely new at this, right? This is all uncharted territory for me. But when feeding out, so we're using the outer edge of the wheel as our point of contact, was producing a much nicer finish, and also seems to be removing more material rather than feeding in. I was using both methods, but yeah, you learn as you go, right? So it's definitely better to have the outer edge of the wheel, especially since we've got it angled slightly, so all the work is happening on the outer edge. Having that be the lead is definitely a better method of feeding. Okay, let me clean this up and we'll do a test fit. Got a real thin coat of Prussian blue on the spindle nose, and I'm going to mount this up and just see what kind of contact we're getting. There is blue here and here. You can see here, there's a tiny bit here. I don't know if it's showing up on camera. And all this has the blue, it's actually the crosshatch pattern that's being transferred from the spindle nose. Yeah, okay. And then our taper looks pretty good. It's interesting how it has, like in this area, how it has a couple of bands that are a little stronger. Yeah, but anyways, I'm going to call this good. All right, I'm going to clean this and put it back on, and then we'll put a piece of material in there and see if we can indicate it in. Okay, I got a piece of, I think this is just some cold roll shafting. It is straight. I checked it on the surface plate. So I indicated it in, and we're running really nice there. That's under half a thou, okay? But if we move the carriage out, you can see what happens. we're not running true axially. So that means the chuck is either slightly cocked one way, or there's something wrong with the jaws, okay? And we did do measurements on the chuck body on the surface plate, and everything looked pretty good. I don't really have a good way of checking the jaws to see if they're 90-degree ground to the chuck body, but I think they are. Each mark is a half thou, so that's 1 thou total run out. And that's what we had when we were doing our setup. We just couldn't get any closer than that. We were fighting the diameter run out versus the face run out. Okay, I've checked every one of these, and hopefully somebody can tell me, I think this is by design. So if we sweep the jaw track toward the center of the chuck, they drop off by 1/1000th of an inch, and they're consistent. Every one of them is the same. So I think they do that to allow for the loading of the jaws so that they stay more or less perpendicular to the spindle, you know, when you tighten them up under load. Okay. Okay, I've been checking the face of our chuck, and it's pretty good. This is our lowest spot here, half a thousandth low. But overall, it's running pretty good. Okay. So that, I like that. That's a good sign. Now I'm going to try to go this way. Let me see if I can set that up. Okay, check this out. Okay, so we're zeroed out here. Work our way in. Starting to drop off a little bit. A little bit more. And a little bit more. That's the same as what we read on the slots. Well, it's about 1.5 there. Okay. And let's see what happens if we rotate. We don't have a lot of load on this indicator, so I think it'll be okay. Okay, same. 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 And let's see if we go back to 0. There we go. So the face of this chuck is slightly dished. Very interesting. Okay, well, I'm hoping you guys can give me some ideas in the comments, but based on what I'm seeing here, I mean, the face is almost dead nuts. I mean, our worst run out spot was a half a thou. It is kind of weird that this is dished. I don't know if that's by design, and we also have these are slightly angled in at 1 thou taper all the way around. And that could be by design. It kind of makes sense. And then this being dished, it looks like this is Blanchard ground by the pattern here. They probably had a pretty good size wheel, and maybe it wasn't trammed in all the way, or maybe it's deliberate that they try to put a little dish in there. So I'm in uncharted territory, so I don't know. We do have a little bit of run out. Let me back you guys off a little bit. Oh, you can see. Yeah, we do have a little bit of run out in the circumference. But I mean, based on what I'm seeing, I think we did a pretty good job on the taper grinding and the back face. So I'm thinking we probably have a jaw problem with trying to get our stock to run true. So let me know what you guys think. That's kind of the way I'm leaning right now. I'm going to put the jaws back in and do one more test, and we'll see how that looks. I put a little mark so we can come back to the same spot. All right, now let's come on out here to this mark. And wow, it's 4.5 plus 3. What's that? 7.5. Wow. Okay, I'm going to try something. I just did an experiment. I flip-flopped jaws 1 and 2. So let's take our readings again. So here we are, just under a thou run out. Okay, let's come back out to this mark. That looks like about 2.5 thousandths. That's a big improvement. It's a jaw issue. I was kind of thinking that all along, but I didn't want to say anything, put the whammy on it. But I think that's our issue. All right, guys. Well, hey, we learned a lot on this project. I got to say, it was a little bit stressful at different points. So now I'm going to probably spend some time flipping and flopping these jaws around, see if we can make any more improvement, although it's looking pretty good right now. So anyways, with that, if you can, please hit that thumbs up button. It really helps. And we will see you guys soon in the next video. Alrighty, bye now.